Hi, Taylor. I'm sorry that we had a miss kind of like step today with our first period Zoom. As you may or may not have heard, Canvas has been on the kind of like in and out all morning. I started to have Canvas troubles as early as first period, and as a result, some people couldn't even check the answer key, and I couldn't get to the Zoom link. So I did by fifth period, so I was able to connect with them. I also encourage you to jump on the seventh period Zoom if you are interested, but since we missed each other, I think it's really important that I provide some other resources. So your question was this: how is polarization different or similar to induction? Because they kind of seem to go together at certain times. Well, what they have in common is that they are both methods, right? They are both ways that charge can move. So charges are mobile, specifically electrons, right, in conductors and to a small degree in insulators, just not very far. But that's about they all have in common, because in reality, polarization is a method of moving charge in which there is a rearrangement of charges caused by an external charge. And what that means is there's an external material, maybe it's a wand or maybe it's a balloon, and it's near one of those, some kind of conductor or even an insulator, and its presence. So say this is a balloon that's been rubbed on fur and it's negative, right? There's negative charges on this balloon. So when it comes near this conductor, that's made of metal, and, sorry, just getting a pen color that will work. And this guy is neutral. That's one possible condition. Well, if it's neutral, that means the number of electrons and protons are equal. But how are they distributed? Well, normally they would be evenly spread out, right, throughout that metal sphere. But now that this balloon is nearby, it exerts a force on the charges that are in the sphere. And because it's a conductor, what we see happen, right, is that the metal sphere becomes polarized. So how would it appear afterwards? Well, the electrons would move to the far side, and relatively speaking, the near side would be positive. So anytime there is a net separation of charges where one side is positive and one side is negative, we refer to that as polarization or polarized. What caused it was the presence of an external charge that of course pushed those electrons. However, it is temporary in this case. As soon as this balloon goes away, the charges will return back to their existing state. Now, polarization can also happen in a charged sphere. And you're like, wait a minute, I'm confused. Can it happen? I thought it had to be neutral. Nope. What if this metal sphere has already been charged by another process? And what if there are extra electrons in here? I don't know, let's make there be 4 of them. But there's also protons in there, positive and positive. So clearly this is a negative sphere. And can it still be polarized? Yeah, so if you bring along a source of charge and you bring it near, it doesn't have to touch it, just bring it near. Well, that metal sphere over here can also be polarized. But now the electrons, how many of them are there? Well, there's probably maybe, I think I counted 4 of them. And so this is an example of polarized and charged. But it was charged before the polarization ever happened, right? Before the force of the negative balloon, right, over here had any effect, right? So it's really the electrons in the source that are repelling the electrons. The object was negative, but there was still a rearrangement, right? So there's a process. As soon as this balloon goes away, the charges would redistribute back to evenly spread out. So polarization is always just a temporary rearrangement of charges caused by an external charge. And it's usually electrons being repelled by a negative source, but could it also be electrons attracted to a positive source? And the answer is yes. Okay, let's go to the maybe one more slide. worth, and let's look at induction. So I can see how induction could be kind of thought of as being a similar process, because induction is a non-contact. Let's spell that right. Let's clean that up. A non-contact method of charging. So charging in this case means creating a net charge, right? Not a neutral object. You are creating a charge, but it's non-contact. So what happens in the material, typically again a conductor, and let's do it in the metal plate that we saw in lab. So there was this metal plate that had an insulating handle on it, and we had an object that was an electrophorus. It was this large plastic surface that had been negatively charged in step 1, right? And this was charged by friction. But nonetheless, here is something called the source charge. And that source charge, right, the metal plate comes down close to the source charge, and that causes, and here's why it's confusing, it causes polarization to happen in this metal conductor. And even though it looks very thin, the electrons can move to the top surface, some of them, not all of them, leaving a relatively few protons on the electrons on the bottom surface, or a positive charge. Even though it's a millimeter apart, that is still considered polarization, right? There is a movement of electrons away from the negative source. But then, if you were to take this plate and move it far away, it would no longer be polarized. However, what if you come along and touch this surface and touch it with your body, your hand, and that's referred to as grounding.
Good afternoon.
And grounding, it usually means to make something neutral, but really what it means is to take away excess charge. So see how by touching the top surface, the electrons are moving through your finger, and they're moving into your body. They're moving away because there is an abundance of electrons on the top surface. So we did step 1, polarization, and then we did step 2, grounding, and those are the 2 hallmarks, or the 2 key stages. There are other ways of doing induction. They always involve polarization and then separating the charges from each other. But the one that we have the most experience with, of course, is this polarization and grounding. The net result of this metal plate, after you have touched the top surface, is that it now has a net positive charge. But notice it never directly touched the source. It was actually a process of grounding that changed the charges. So, right, we never contacted the source. And furthermore, do you notice that it's the opposite charge of the source? And those are 2 kind of key features of the result of induction. I hope that helps, and I'll send this off to you in an email as soon as I can.